The objective of our project is to measure the resistance in multiple strain gauges to control the operation of different motors.
Strain gauges are used to measure deformations in solid objects. It is made up of thin metallic foil attached to a carrier and a forming grid.
When bonded properly to the specimen using a cyanoacrylate-based adhesive, any change in deformation of the specimen will be detected by the strain gauge and transferred through the lead wires. The resistance of the strain gauge will decrease when it's under tension and increase when it's being compressed.
The building block of this system first requires an input signal taken from the strain gauge bending that was drawn from the glove and having the strain gauge placed on top of it. As the strain gauge bends, it will cause a change in its resistance, and the signal will be gathered by the data acquisition system and inputted in the LabVIEW to read its program and apply adjustment in order to give an output from the data acquisition system. The output will be drawn to the motor that drives the conveyor belt, which is used to run the motor more smoothly. As the motor starts to run, the user has a chance to perform a forward, left, or right motion, which comes out as a T shape.
Our design has many applications, one of which includes improving accessibility for disabled people. So a lot of people with disabilities have limited range of mobility in their arms and hands. Our system allows for just the slight movement of your fingers to control the wheelchair and drive forward. However, our design is not limited to just this application. There's many more that it can be applied to.
Another example of an application for our system is in the military for the use of controlling drones. Our system is more ergonomic than the traditional hand controller and allows soldiers to control the drone from a secure and discreet location.
The potential for application is virtually limitless. Aside from the military technology and the wheelchair, it can also be used in medical surgery or other medical operations. For instance, surgery can be done at microscale, which allows for less invasive and more finer operations on patients, possibly benefiting the medical industry. Also, it can be finer tuned to, instead of using the strain gauge, to a strain chip, and that can be implanted in tongues, so that you can use finer movements and allow for wider usage in the paralyzed person.
Our system has a great potential in healthcare and military, and the list goes on. With our project, we hope to have a spark in this field for the betterment of our society.